This is your internalization video for the 6th grade Excel curriculum, lessons 64 and 65. This week, students are going to learn and practice how to generate equivalent expressions and how to factor and identify equivalent expressions. Your first lesson is students generating and identifying equivalent expressions. So in this first example, we are given 5 y's that we are adding together, y plus y plus y plus y plus y. So students should first identify, yes, I see a series of y's, and I see 5 of those y's, and the coefficient, meaning the number in front of them, is always a 1. And they're asking me to add them. So I can add a 1 in front of them to make it easier to see how many y's I have. And adding this series of 5 y's gives me 5y. This is the most direct way to add expressions or to generate an equivalent expression. I'm now going to write an equivalent expression using the distributive property. The distributive property tells me that I distribute the number on the outside of the parentheses to every number on the inside of the parentheses. And we distribute using multiplication. So I'm going to multiply 7 times 4, and again, I'm going to add that to 7 times x. 7 times 4 is 28. 7 times x is 7x. My equivalent expression is 28 plus 7x. In the try it problem, you really want to lean in here. You want to write an expression equivalent to m times m times m. Students are going to be inclined to say this equals 3m. But you're going to have to highlight that this expression does not look the same as that expression. In the first expression, we are adding. In the second expression, we are multiplying. Therefore, m times m times m does not equal 3m because addition is not the same as multiplication. Instead, because I have 3 m's, I'm going to multiply them to a power. So m times m equals m to the third power. You can give them another example. Y times y is going to equal, I have 2 y's there, y to the second power. P times P times P times P. How many P's do I have? 4. Great. That is P to the 4th power. Really lean in and help kids see the difference between adding and multiplying here, so that when they get to the practice problems, they are able to distinguish between questions 1 and 2 and question 3. And as students go through problems 1 through 12, they are practicing the same steps that they went through in the first example, in the examples. When they get to questions 13 through 18, this looks a little bit different than what they've experienced. And they're asked here to use the GCF to write an equivalent expression. I would model question 13 for students. In this expression, 2y plus 4, I am going to ask myself, what is the greatest common factor between 2 and 4? I know that 2 goes into both 2 and 4, so I'm going to write that down. Now, when I find the greatest common factor, I need to divide. I need to divide 2 divided by y. That's going to leave me with a y. And 2 divided by 4, that's going to leave me with a 2. And then I bring down my addition sign. So I'm doing the inverse of the distributive property here. And then I would allow students to try questions 14 through 18. Students are going to have the opportunity to continue this practice as they jump into the next lesson, where again, they're using the greatest common factor to write equivalent expressions. So we're starting with 40a minus 24b. And I have to ask myself, what is the greatest common factor of 40 and 24? It is 8. So now I'm going to have to rewrite this expression with factoring out the 8. So if I look at 40a, that is 8 times 5a. And if I look at 24b, that is 8 times 3b. That common factor I have here is that 8. So I write that on the outside of my parentheses. And what I have left is 5a minus 3b. Students might get tripped up when identifying the greatest common factor. They might look at 40a minus 24b, and they might say 4 is the greatest common factor. And you can show them that if I pull out a 4, that's going to leave me with 10a minus 6b. And you can ask yourselves, if I look at those two factors, is there still another greatest common factor? Yes. That means I didn't pull out the greatest common factor. So you really just want to make sure kids identify the greatest number. Students are then going to combine what they've done in example C with what they did yesterday. And they're going to look at two expressions and identify whether or not they are equivalent. So in example D, I am going to have to use the distributive property to write an equivalent expression here, which gives me 40x plus 32. And then I'm going to simplify 4x plus 18 plus 14, which also gives me 4x plus 32. Therefore, these expressions are equivalent. They're going to use the same process in the discussion question. And when students get to the practice, they are going to use the same skills that they just practiced in the examples. What you want to see as you look at questions 19 through 22 is that students are showing you their work. So you want to see the equivalent expressions that they are generating. For every question, you want to make sure that they aren't just circling answers, that you see their equivalent expressions.